Hi everyone, welcome to another lecture on circuit theory. In this lecture, let us discuss some additional problems on mesh analysis. In this lecture, let us discuss problem number 1, calculate 5 ohm resistor of this circuit. Problem number 2, calculate power delivered by each source for the second circuit. In problem number 3, calculate power consumption in 8 ohm resistor of the following circuits. These are the three problems I am going to cover on this lecture. Problem number 1, calculate current in 5 ohm resistor of the following circuit. Step number 1, select loop current and branch current direction. How to choose loop current? Randomly you can choose loop 1, loop 2 and loop 3 all clockwise direction. Now we have to identify branch current direction here. Let me start from this 2 ohm. 2 ohm has only I2, so this branch current is I2. And this 1 ohm resistor has only I3 current flow, so this is I3. Coming to this 10 ohm resistor, I1 current downward and I3 current upward. So let us fix downward direction of current flow. That means I am assuming I1 is greater than I2. So this is going to be I1 minus I2. And coming to 5 ohm resistor, I1 is downward, I3 upward. I am assuming a downward direction. So I1 minus I3 is my current flow here. Then we have one more branch, 3 ohm branch, where current source is given but the direction is clearly defined towards the left. So here you can write the current in terms of loop currents. So this is a direction given, so which is in I2 direction. So I can say this is going to be I2 minus I3. This is how loop current and branch current directions are fixed. Let's move on to step number 2. Write down KVL equation from mesh number 1 and then remove common current source between meshes 2 and 3 and write down the equation that represents common current source in terms of loop current. Consider loop number 1. This is my loop number 1. Apply KVL on this, write down equation number 1. From mesh 1, let me start from any one of this point and end with the same point. I'll start from this 50 volt source. On a 50 volt source, loop current leaves a positive of the terminal plus 50 here. Then coming to another element, this 10 ohm. Actually 10 ohm has a branch current of I1 minus I2. So loop current, branch current both are same, so minus 10 I1 minus I2. Then coming to next one, here 5 ohm. 5 ohm has the branch current of I1 minus I3, which is also in direction with loop current, so minus 5 times of I1 minus I3 is equal to 0. Then you rearrange this equation, you may find 15 I1 minus 10 I2 minus 5 I3 is equal to 0. Now look at 2 amps current source which is present between mesh 2 and 3. That means this problem not been solved by ordinary mesh analysis. We have to go for super mesh analysis. You have to remove this current source and write down this current source value in terms of loop current I2 and I3. Since a current source between two meshes or loop, the problem may be solved by using super mesh analysis. So from this current source, so I can say I2 minus I3 is equal to 2 amps. So I got second equation. Then remove this source, take loop number 2 as well as loop number 3 together, write down the KVL equation. This portion completely removed from the circuit and then write down the equation. Let me combine these meshes together and write down the KVL equation. Mesh 2 and 3, you may get 10 I1 minus I2. This 10 I1 minus I2 with a plus sign because your second loop current flowing opposite to this branch current I1 minus I2. So plus 10 I1 minus I2. Coming to this portion, so I2 current is only flowing through this way, so minus 2 I2. In fact, both these two directions are same, so minus sign 2 I2. Then coming downwards, I3 is the only current flowing, so obviously the current direction remains same, the branch current as well as loop current, so minus I3. Considering loop 3 current on this 5 ohm branch, this branch current and loop current opposing each other, so plus 5 times of branch current, so 5 into I1 minus I3. This is equal to 0. Rearrange equation, you may find 15 I1 minus 12 I2 minus 6 I3 is equal to 0. So these are the three equations. Now move to step number 3. Solve these three equations and find out loop currents. These are the three equations we found in the previous circuit diagram, and solving this equation using calculator, you may get I1 as 19.99 amps, I2 as 17.33 amps and I3 as 15.33 amps. Now find out the current in 5 ohm resistor. This is the actual question. Let me go back to the question. 5 ohm resistor is here, so current flow in 5 ohm resistor is I1 minus I3. Let's calculate current in 5 ohm resistor. I1 minus I3, that is 19.99 minus 15.33, it is 4.66 amps. This way you may conclude the solution for the problem number 1. Let's move on to problem number 2. Problem number 2 is calculate power delivered by each source. So there are three sources here, namely 40, 10 and 60 volt source. I want to find out power delivered. So whatever be the case, we are supposed to find out loop current here. As usual, step number 1, select loop current and branch current direction. Select loop current as you wish. I1, I2, this is your current I3. In fact, loop current I3. Now consider this 12 ohm, only I3 current is flowing. Let me take here the current as I3. Considering this 5 ohm, here I2 is flowing towards my right and I3 is flowing opposite. I have to choose one direction here. I am assuming I2 is greater than I3, so that towards my right I have chosen this current direction. Similarly here I am choosing right. Once again I am assuming I1 is greater than I3, so I1 minus I3 here. Coming to the 7 ohm branch, I'll choose downward. That means I am assuming I1 is greater than I2, so branch current is I1 minus I2. So I have chosen all loop currents are clockwise, and based on the loop current I have given branch current direction for each of the branch. But the actual question is to calculate power delivered by each source. That means I want to find out what is the current flow through this 40 volt source, what is the current flow through this 10 volt source, and what is the current flow through 60 volt source. In fact, I found that current flow through this 60 volt source is only I2, because no other current is flowing here. current flow through this 40 volt source is only I1. And current flow through this 10 volt source is already marked here I1 minus I2. Let's move on to step number 2. Apply KVL in each mesh and write down the equation. Now apply KVL on loop number 1. This is my loop number 1. Apply KVL. Let's start from this point. So moving towards top, 40 volt source, loop current leave positive, so plus 40. Then coming to this side, branch current, loop current, both are in the same direction. So minus 4 times of branch current, that is 4 into I1 minus I3 is your voltage drop. Then coming to this one, this I1 current leaving negative of this 10 volt source, so minus 10. And further, this loop current I1 and the branch current of 7 ohm, both these two in same direction, drop is I into R. I1 minus I2 is a branch current, the branch is 7, so 7 times of I1 minus I2. So no further element is here, so equate the same to 0. So this way mesh 1 equation is obtained. By rearranging the equation, you may get 11I1 minus 7I2 minus 4I3 is equal to 30. Then moving to mesh number 2, I'm taking this as loop number 2 and write down this equation. Let me start from this 10 volt source. Loop current 2 leaving positive of this 10 volt source, plus 10 here. Then moving on this side, this 5 ohm branch current I2 minus I3 is in direction with loop current I2, so that minus. Then the drop is 5 times of I2 minus I3 voltage drop. Moving downward, this loop current I2 leaving negative of this voltage source, so minus 60 represented here. And further moving towards this point, I'm seeing a 7 ohm resistor. So 7 ohm resistor branch current I1 minus I2 opposite to this branch current I2, so that we have plus here, and potential drop is 7 times of I1 minus I2, which is equal to 0. Rearranging this equation, you make it minus 7I1 plus 12I2 minus 5I3 is equal to minus 50. Now let's move on to loop number 3. This is my loop number 3. Write down the equation now. Now consider this 12 ohm branch, I3 loop current in the branch current is also I3, both in the same direction, so minus 12I3. I'm moving down towards this loop, acknowledging 5 ohm resistor. This 5 ohm resistor has I2 minus I3 as a current, which is opposite to this loop current I3. So plus drop is 5 times of I2 minus I3. Then moving towards this loop, 4 ohm resistor is seen here. 4 ohm loop current is I1 minus I3. This is also opposite to this loop current I3. So plus 4 times of I1 minus I3, then no other element is available, which is equal to 0. Then rearrange this equation, 4I1 plus 5I2 minus 21I3 is equal to 0. And next step, solve all these 3 equations and find out loop currents. So these are the 3 equations we found for the earlier circuit. Solving these equations, we may get I1 as minus 1.546 and I2 as minus 5.763 amps. Finally, I3 as minus 1.667 amps. I'm getting minus sign everywhere here. That indicates that whatever the loop current direction I have chosen, that is wrong. But I can assure you the magnitude of current whatever I found is right. Say for example, I have assumed all the 3 loop currents are clockwise direction, but in actual practice all the loop currents are anti-clockwise. That is what the result indicates. Nevertheless, the magnitude of current remains same. Step 4 is to find out power delivered by each source. Power delivered by 40 volt source. What is the current flow in 40 volt source? I1. So 40 times of I1. Now check it, what is the current flow through 40 volt source? I1. So P is equal to VI. That is a formula I am using here, 40 into I1. Similarly, what is the current flow through 10 volt source? I1 minus I2. So P is equal to V into I. V is 10, I is I1 minus I2. Similarly, for 60 volt source, your power delivered is P is equal to 60 into I2. Use this formula and find out power in each source. So for 40 volt source, 40 times of I1, which is 61.84 watts. For 10 volt source, power delivered is 10 times of I1 minus I2, which is 42.7 watts. On a 60 volt source, 60 times of I2, which is 345.78. But notice one thing, on all the three cases I have chosen magnitude of current, I haven't considered sign. So 40 times of I1 magnitude alone 1.546. Likewise, in the third case, 60 times of I2, only I considered magnitude of current. But coming to power delivered by 10 volt source, I have chosen I1 minus I2. That means I have to substitute properly what is the value of I1 as well as I2. Then you find out net result. That gives proper answer as 42.7 watts. On a problem number 3, calculate power consumption in 8 ohm resistor of the following circuit. I have 8 ohm resistor here. I want to find out current flow through this 8 ohm resistor so that I square R becomes power consumption on this resistor. For that, I want to find out loop currents here, thereby current in 8 ohm branch. As usual, let's select the loop current and finally branch current direction. I'll select all clockwise once again. Mark branch current from this area, 4 ohm or 8 ohm, doesn't matter. It takes I1 current because only I1 is flowing here. And similarly here 2 ohm branch, I2 is a branch current since I2 is the only current flowing through this way. And coming to this 10 ohm and 3 ohm branch, here I3 is the only loop current flowing towards this particular area. Coming to this 1 ohm branch, which is common for loop number 2 and 3, where I2 is downward and I3 is upward. So let me assume that I2 is greater than I3. So branch current on 1 ohm is I2 minus I3. Similarly, coming to 4 ohm branch, there are 2 loop currents, I1 downward and I2 upward. Let me assume that I1 is greater than I2. That means I1 minus I2 is my branch current here. So I have concluded loop current as well as branch current. Let me move on to step number 2. Step number 2 is apply KVL in each mesh and write down the equation. Now let me take loop number 1. This is loop number 1. Apply KVL on this loop. Let me start from this point, 10 volt source. Loop current I1 leaving positive of this voltage source, so plus 10. Then moving further, 4 ohm. I1 is the only current flowing. Loop current, branch current both are acting in the same direction, so minus 4 times of I1. And so as in 8 ohm, I1 is the only current flowing, so I1 loop current, branch current both are same and in the same direction, so minus 8 times of I1. Then coming to this 4 ohm branch, branch current I1 minus I2 according to my assumption, I1 downward, once again both these two in the same direction, so minus, the drop is 4 times of I1 minus I2. So here I have 5 volt source, loop current I1 leaving negative of the voltage source, so minus 5. So this way you can find out the equation and equate the same to 0. Finally rearrange the equation. You could see 16I1 minus 4I2 is equal to 5 as equation number 1. Now let's move to loop number 2 and write down the equation. Let me start from this 5 volt source. Loop current 2 leaving positive of this 5 volt source, so plus 5. This loop current I2 moving opposite to 4 ohm branch current, that is I1 minus I2. So we have to write plus 4 times of I1 minus I2. Coming to this 2 ohm branch, so only I2 is flowing, both the directions are same, so minus 2 into I1 minus I2. Then moving further, I have 1 ohm branch. On this 1 ohm branch, current flow is I2 minus I3 according to my direction, that is downward. The direction of this I2 minus I3 and the direction of loop current both are same, so minus. The drop is 1 times of branch current, 1 into I1 minus I3. Then don't forget I have one more voltage source here, loop current 2 leaving negative of the voltage source, so obviously minus 8. Then equate the same to 0 and rearrange the equation. We make it minus 4I1 plus 7I2 minus I3 is equal to minus 3 as equation number 2. Then coming to loop number 3. On this problem, write down the KVL equation. Let me start from this 8 volt. Loop current I3 leaving positive of the voltage source, hence positive 8. Then 1 ohm resistor has I2 minus I3, which is downward direction of current flow, but loop current I3 is upward. Both are opposite, so plus 1 times of I2 minus I3. Further, this 10 ohm and 3 ohm takes only I3 as a current, so I can say minus 10 I3 and minus 3 I3. Further, I have a voltage source, loop current I3 leaving negative of the voltage source, so minus 20, which is equal to 0. As usual, you just find out manipulated equation. I got minus I2 plus 14I3 is equal to minus 12 as equation number 3. Then on step number 3, solve all 3 equations to find out loop currents. These are the 3 equations we found in the earlier problem, and finding the solution using calculator, I make it I1 as 0.2026 amps, I2 as minus 0.44 amps and I3 as minus 0.88 amps. That means a second loop current and third loop current direction, whatever I assumed is wrong. Actually I assumed clockwise, but in actual practice it is anti-clockwise. Then coming to step number 4, find out power consumed by 8 ohm resistor. Let me go back to the problem once again where I have 8 ohm resistor. So have a look at this one. 8 ohm resistor has a current flow of I1. So I1 square into 8. That's your answer. Power consumed by 8 ohm resistor is I1 square into 8. So substitute I1 value here and find out the solution as 0.38 watts. I hope you understand all the mesh analysis problem. For more update, subscribe my channel.